Hello students, so today let's start with this 9.15 and 9.16. Number of questions in this DPP is relatively more than the other DPPs, but so many questions are of same type, right? As far as if we come to the question number one of this level 1. This is one of the question, but there are 2-3 questions, 3-4 questions of same type is already in this DPP. See, if we just try to solve this question, it says that suppose there is a set A, right? And let us say it includes n number of elements, A1, A2, and that goes up to an elements, right? So it is saying that we have to construct two subsets of this set. Let us say P is one of the set, and which is what this P is what the subset of A, right? By taking some or more elements of A, and similarly we have to find out the subset of A, another subset of A, that is Q, right? The question is, in how many ways these subsets can be formed, P and Q can be formed, so that P intersection Q equals to 5. Means none of the element is common as far as these two sets or subsets of A is concerned, right? So just for the hint, what we do, if we take A1, right? So this element A1, either it may remain in A, or it may go to set P, or it may go to set Q. So as far as A1 is concerned, we have 3 way outs. Either A1 will remain in the set A, or it can go to set P, or it can go to set Q. Means A1 can be distributed in 3 ways. 3 ways. And so on. The same is true for A2, A3, An, and all. In the same manner, if we just distribute all the elements of set A, finally the set A, P, and Q will be such that none of the elements in these 3 sets will be in common, and this way you can find out the answer. Right? Now if we come to question number question number 2 of this level 1, question number 2 of level 1 and question number 1 of level 2, they are of same kind, right? And let's say in this type of questions we can try. Now if we come to this question number 3, this question is based on function. This question is based on function. If we come to question number 3, in this question it is said that we have to form the number of functions. We have to define the number of functions from set A to set B, and set A includes A1, A2, A3, A4, A5, 5 elements, and set B we have 3 elements. Let's say B1, B2, B3. The question is how many functions can be formed so that the functions are onto, right? As we already know that as far as onto function is concerned, range of this function should be equal to codomain. Range of this function should be equal to codomain, right? So as far as hint for this type of function is concerned, we can say that it can be treated like, or it can be dealt like we have 5 balls, and 3 boxes are there. 5 balls and 3 boxes are there, and we have to distribute these 5 balls in 3 boxes, in such a manner that none of the box may remain empty. Suppose if say A1, A2, A3, A4, A5, all of them if gets related to B1, in that case your range will be B1, but the codomain is B1, B2, B3, the function will not be onto. So that's why what we need to do, we need to relate these elements A1, A2, A3, A4, A5 to the elements of set B in such a manner that all the elements are related to all the elements of set B, so that the function becomes onto, right? Similarly, as far as 1-1 function is concerned, it should be kept in mind that each and every elements of the set A should be related to the elements of set B in such a way that that none of the element in A is related to more than one element in B. Right? As for example, suppose if someone says that A1 and A2 if gets related to B, then in this case it will not be a 1-1 function, that will become many-one function. So this thing what we need to keep in mind in order to find out 1-1 function, right? And if we have got the total number of 1-1 function, then by subtracting it from the total number of function we can get number of many-one functions. Right? Now if we come to this one, there is a question